In this video, I'm going to demonstrate the logarithmic regression model through Excel. A logarithmic regression model is of the form y equals a plus b times the natural log of x. First, a look at our data. Our data is for cordless screwdrivers and is the price demand and the price supply. That's a table of price demand and price supply. So let's look at our data. If the price, so in our demand column, if the price of the screwdriver is $73, customers are expected to buy 2,000 screwdrivers. If the price of the screwdriver is only $56, customers are expected to buy 4,000 screwdrivers. Looking at supply, if the company can sell screwdrivers at $26, they're willing to sell 2,000 of them. If they can receive $38 for them, they're willing to sell 4,000 of them. So these are our functions. We're going to try to fit them using a logarithmic regression model. So instead of using the 1,000, 2,000, 3,000 as the x values, we're going to look at the natural log of those numbers as the x values. We can do that fairly naturally using the linest function, where we use the known y's. So this is supply, the known y's. And then instead of the known x's being the 1,000, 2,000, 3,000, we're going to make it the natural log of those numbers. And remember, the natural log is a single cell function. Natural log of the number is that number returned. But if used in an array context, ln of A3 colon A7, it will return an array of numbers, natural log of the first number, natural log of the second number, and so on. So this is going to do a linear regression on the natural log of the x values. So I do Control-Shift-Enter to tell Excel this is an array formula, and we get regression coefficients. I do the same thing for the demand. So we'll do the demand, and we can do a structured reference here. Oops, and we forgot the ln already. So ln of screwdrivers, open bracket, number, close bracket, close parentheses again, Control-Shift-Enter. I forgot to do it as an array formula. On two cells, I can simply edit the cell, F2, and then Control-Shift-Enter again, and I get my array formula. I get both coefficients. I go down here to my calculations, and I'm going to use my usual series sum. But now instead of passing x, I want to take the natural log of x. So the natural log of 6,145. 1, negative 1, because this is linear, supply, equals series sum natural log of x, 1, negative 1, demand. Turns out the 6,145 is the equilibrium price. If the company sells for $47, they are willing to sell 6,145, and if the price is $47, people are willing to buy 6,145. If I wanted to find this, let's say we're selling 50 of them. Oops, that's not a good number. How about 1,000 of them? Supply and demand are not in equilibrium. If I want to find the equilibrium, I can. I have the difference between my supply and demand, my prices. So I can go to data. What if, goal seek, I want to set the difference to 0 by changing the number of screwdrivers? 6,145 is our equilibrium number of screwdrivers. The equilibrium price is $47. And that concludes our demonstration.